eyepieces do? How much do they magnify? How wide is the field of view? What does exit pupil mean? How many eyepieces do you need? These are some of the topics I'll try to cover in the few minutes that I've got to talk tonight. Now, unfortunately, to Ken, we're not going to talk about these eyepieces. No iPhones, iPods, iPads, or such eyepieces.
Very old picture.
So what do eyepieces do? The objective lens in a refractor, or the mirror in a reflector, collects light and rigs its focus, creating an image. The eyepiece magnifies the image. So here you see the objective, and you see the point where the lines cross is where the image is brought to focus, and then the eyepiece is going to enlarge it for your eye. How much does the eyepiece magnify the image? The magnification you can calculate is the focal length of the objective lens or mirror divided by the focal length of the eyepiece. The focal length of the objective lens or mirror is often called the focal length of the telescope. So here capital F represents the focal length of the objective, or so-called telescope focal length. And the lowercase f represents the focal length of the eyepiece. How much magnification do you need? Small objects like planets need a lot of magnification. Large objects like open clusters need low magnification. So you need to have eyepieces to give you both high and low magnification. What's the field of view? The apparent field of view is the width of field you can see by looking through the eyepiece alone at unfocused sky. If you had no telescope and you just held the eyepiece up to the sky. This is the field you see advertised. So when you see an advertisement saying an eyepiece gives a 50-degree or a 70-degree field of view, of course you're not going to see 50 or 70 degrees looking through the telescope. This is just the apparent field of view. The true field of view, if you actually see through a telescope, depends on the telescope that you put that eyepiece on. The true field of view is the apparent field of view divided by the magnification. In my opinion, the bigger field of view is always better. And here are the three reasons that I think we always would want as large a field of view as possible. Number one, large objects fit within the field of view. Number two, you can see an object contrasted against its surroundings when you have a larger field of view. And number three, and I think to me most important, it's easier to find the object you're looking for when you have a large field of view. So even if you have a go-to telescope, it's often not exactly centered on the object you want. So if you have a large field of view, it's much more likely the object you're looking for is someplace in that field of view. There are two ways to get that bigger field of view that I want and that I think all of us want. You can use an eyepiece with a lower magnification. A 10 millimeter 50-degree eyepiece and a 1,000 millimeter telescope gives a magnification of 100 power, true field of view of 0.5 degrees. In that same telescope, the same 50-degree eyepiece, but you put a 25 millimeter eyepiece in, you have a magnification of 40 power and a true field of view of 1.25 degrees. Now it may seem that it's only a little more than double to go from 0.5 degrees to 1.25 field of view, but that's not true because that's the diameter, not the area. If you want to compare the areas of those two fields of view, you have to use the square. So the square of 1.25 degrees divided by the square of 0.5 degrees tells you that you get 6 times as much viewable area of sky when you increase the field of view in this way. Now the other way to get a larger apparent field of view is a more expensive way, and that is to buy an eyepiece that has a larger apparent field of view. A 15 millimeter 50-degree eyepiece and a 1,000 millimeter telescope gives a magnification of 67 and a true field of view of 0.75 degrees. The same 15 millimeters eyepiece, but a 100-degree apparent field of view, and that same telescope gives the same magnification, but now the field of view is 1.5 degrees. And again, at first glance you'd say 1.5 degrees is twice as much as 0.75 degrees. But when you're considering the area, not the diameter of the field of view, if you take 1.5 squared divided by 0.75 squared, you find out you have 4 times as much viewable area of sky when you've got that eyepiece with a wider field of view. What about exit pupil? The exit pupil is the width of the cone of light that comes out of the eyepiece. Young people have a dark adapted exit pupil around 7 millimeters. For old people like me, it's only 5 millimeters. If the exit pupil of the eyepiece is larger than your own eye pupil opening, then some of the light your telescope has collected is wasted and doesn't help you see as bright an image. To calculate the exit pupil, divide the aperture of the scope's objective mirror or lens by the magnification of the eyepiece. or you can divide the eyepiece focal length by the F ratio of the scope. An example, in my 8-inch scope, 203 millimeters is 8 inches. With a focal length of 2,032 millimeters, you put in a 20 millimeter eyepiece, the exit pupil of this combination is 2 millimeters, which you can calculate two different ways. 2,032 millimeter focal length of the scope divided by 20 millimeter focal length of the eyepiece gives you 102 power magnification. 203 millimeters or 8 inches diameter of the main mirror divided by that magnification tells you 2 millimeter exit pupil. The second method is to take the 20 millimeter focal length of the eyepiece divided by 10, the F ratio of the telescope. Same answer, 2 millimeter exit pupil. Eyepieces come in 3 different diameters. Some very old or very cheap telescopes use eyepieces with just 0.965 diameter. But that size isn't used in the telescopes we use today. Most amateur telescopes come with standard eyepieces with barrels of 1 1/4 inch diameter. You can get a wider field of view if you use eyepieces with a 2-inch diameter, but you might need an adapter on your telescope to take those larger eyepieces. Here we see a picture of a pop can compared to the 3 different sizes of eyepieces, 2 inches, 1 1/4, and 0.965 inches. How many eyepieces do you need? Well, most of us have more than 3 eyepieces, but I think you really only need 3. One for low magnification, whatever focal length will give you around 30 to 60 power. One for medium magnification, whatever focal length in your scope will produce a power around 90 to 120. One for high magnification, whatever focal length you need in your scope will give you 200. Or if you have a large scope, then you can go up to higher power than that. Just to briefly mention, a Barlow is a special kind of eyepiece that you put between your telescope and your regular eyepiece and has the effect of doubling or tripling the magnification. There's 2 power and 3 power Barlows. If you get a 2 power Barlow and you have only 3 eyepieces, it effectively doubles your number of choices because you can use each of your 3 eyepieces with or without the Barlow. A reticle eyepiece is one more specialty eyepiece I want to briefly mention. A reticle eyepiece has an illuminated or an unilluminated crosshair in the field of view to help you perfectly center your alignment stars. You know, when you're trying to line up the alignment stars in your go-to telescope before it goes to anything, you've got to get those alignment stars right in the center of the field of view, and that's hard to determine exactly where the center is. So a reticle in the eyepiece will help you do that. Let's take a short look at my eyepieces. I keep them in this aluminum case that I got from Orion. It comes with a foam padding, helps you keep your eyepieces safe. My low power eyepiece is a Meade 4002X, has a focal length of 36 millimeters. It's a 2-inch diameter eyepiece. Apparent field of view is 70 degrees. I paid just $100 for it about 7 years ago. They don't make this one, but Orion has a very similar one, called 8829Q70. That's also $100, a 70-degree eyepiece. In my Celestron SCT 8-inch scope, it has a focal length of 2,032 millimeters. This eyepiece gives me 56x magnification and about 1 1/4 degree true field of view. My medium power eyepiece is a Pentax SMC XW. It has a focal length of 20 millimeters, diameter 1 1/4 inches. Apparent field of view is 70 degrees. And I paid $300 for this one. It's still being made, still about that same price. In my Celestron 8-inch SCT, it gives me 102 magnification and 0.69 degrees true field of view. And my high power main eyepiece is a Celestron Axiom LX, focal length is 10 millimeters, diameter is 1 1/4, has an apparent field of view of 82 degrees. I paid $180 for it about 6 years ago. It's no longer being made, but I easily found similar ones for about that price and even a little less on the web. In my Celestron 8-inch, it gives me a 200 power magnification and 0.4 degrees true field of view. But I think it's a little different if I was buying them today, since all my eyepieces are a few years old. When I bought my current eyepieces, you couldn't get the wide field of view you can get today. So if I were buying my eyepieces today, I'd prefer all of them to have 100-degree or higher field of view. Such eyepieces are very expensive, but I think the best priced, high-quality ones today are by Explore Scientific. If you can afford them, my suggestion would be get their 100-degree eyepieces in a couple focal lengths, such as their 9mm 100-degree for $340, and their 25mm 100-degree for $700. Now, if you want to spend a lot less money than that, but not have quite as wide field of view, Orion makes these eyepieces with 68 to 70-degree fields of view, And I picked three to show you low, medium, and high power, 8 millimeters, 26 millimeters, 38 millimeters. They're priced $100 to $145. So you still can get a larger field of view than the one that came with your telescope. Usually your telescope came with a 50-degree field of view eyepiece, so you can expand it to a 70-degree field of view eyepiece for not too much money. Are more expensive eyepieces worth the money? Well, it's not only the field of view, but the optical quality varies among different eyepieces as well. So you can spend $100 or $1,000 or more on an eyepiece. The only way you can learn whether any particular eyepiece is worth its price to you is to look through it. Fortunately, you belong to an astronomy club. Come to our club observing nights, the events at other areas such as Great Lakes Stargaze, and ask the people there what eyepieces they're using in their telescopes. Take a look through their eyepieces, compare, and decide for yourself. And keep looking up. That's the secret of it. Jim?
John, you didn't mention a focal reducer, which is the opposite of a far line.
You want to tell us about that? You get a wider field of view.
Right. It essentially cuts your focal length in half, or you get it in different ratios. Focal reducer is a very good accessory in addition to the bar line. Getting more flexibility with your eyepiece.
The most common focal reducer is 0.6 or 0.63, I think. So you can expand your field of view with that. Other comment? Huh?
You didn't mention zoom eyepieces. I have an 8 millimeter to 24 millimeter television zoom that's an inch and a quarter. Works pretty well.
I have never owned one. I have understood that zoom eyepieces don't give you as good an image as an eyepiece that isn't a zoom. Is that true or not true?
Well, the one I have tells me is very good.
What's the price of that, do you know?
Yeah, it was $300. I have a range of 8 to 24 millimeters.
It sounds good.
And I found on the west coast, someplace, I don't remember where, I looked it up. I found a Chinese knockoff that was the same 8 to 24 millimeters.
In Harry?
What?
Is it in Harry?
No. And it's almost as good, not quite, but I mean, for $65, it's exceptional. And what I like about it is for certain types of viewing is you have the flexibility of not having to take everything out all the time.
Yeah.
Some nights that's about the only eyepiece I use.
I think in order to have time for our break, we're going to have to break here. Let's thank John.